Hello. Normally I feature audio and video technology on this channel, but occasionally we do something else, and today it's something to do with fixing a 1972 Hillman Avenger. So the problem was that the temperature gauge was sometimes reading very high, even from just starting the car cold. So it was obviously a problem with the sensor. And actually I'd taken the sensor out, and at one point I dropped it. And it's worked fine ever since, but clearly the sensor needed replacement. So I bought a new sensor, and this is the other way around. This reads too low. So when the temperature of the car is fully up to normal, you can tell it's been running for some time, it's only just creeping off the cold position on the meter. So what I need to know is what the resistance of this is at the sort of temperature a car would normally run at. Now I don't know what the sort of temperature a car would normally run at, the cooling system, but I'm guessing it's around 100 Celsius, in that order of things. So I'm going to use a hot air gun to warm this up. We're going to measure the resistance, which I think should fall to around about 60-70 ohms, something like that, and we can check the temperature this is at with a thermal imaging camera. Right, let's set that up. Okay, the first thing is I have a meter set up across this, and I just want to prove that I have good continuity between the body of this and the meter which is connected to the vise. So if I short out the sensor, we're getting a fraction of an ohm. So that's proven that we have good continuity from the body out to the meter. So now I need to heat this up to, say, around 100 Celsius. I can use hot air gun for that. I'm going to configure the hot air gun for a little over, around about 125, and then we can check that we have got this to 100, and we'll see what resistance we get on this. At the moment, what resistance do we have? At the moment we're around about 2.7k at ambient. Right. So I've set my hot air gun to 120 Celsius, which will hopefully allow for some losses, because of course the vise is going to act as a heat sink. And we have thermal imaging camera. The thermal imaging camera says the hot air gun is quite a lot hotter than its stated output temperature. It's around about 140. But of course we're trying to get this sensor up to 100 or so. One of the things you need to be mindful of is the emissivity of the surface. So this is a shiny metal surface, and it can somewhat affect the readings. What I might do is take the end cap off the hot air gun and allow this to sit in the hot air flow a bit more. Unfortunately, with a reflective surface, I just can't read the temperature of that brass component. So I'm going to have to give up on using the thermal imaging camera for this and use the thermal sensor that came with the multimeter. Just to confirm, I mean, we're never going anywhere lower than about 200 and something ohms on this. So we can switch this over to the temperature gauge range on the Type K thermocouple, whilst keeping the air in that position. Okay, so we're in temperature measurement mode here, 21 Celsius ambient. Put that in front of the hot air gun, and it should go up to about 100 or so. Yes, it's doing that. Actually quite a bit higher. So now let's measure the temperature at the sensor. Around about 88-90 degrees Celsius on the sensor edge. So we would surely say that that's equivalent to a car that's reasonably well warmed up. Yes? It may not be up to full working temperature, but it should be well warmed up. But the resistance of the probe, wherever I put the hot air gun, I can't get this to read lower than, well, I don't think I've gone even as low as 200 ohms, which would explain why the needle on the temperature sensor is only just moving off the cold setting on the temperature gauge. Just in case anyone was concerned that the vice would have been acting as a great big heat sink, which of course to some extent is true, let's heat the sensor directly whilst not being connected to the vice, and again try to get down to the order of less than 100 ohms on this sensor. And now, even with the most extreme heating I can manage, which is taking this thing up to about 100 and somewhere between 120 and 140 Celsius, which would be an overheating car, I'm still only getting down to about 150 ohms. Well, that's still very hot, so I think we can safely say that I've proven that this is out of spec. That was an interesting little experiment. I'll do plenty more content shortly, mostly on audio and video technology. Bye for now.